And blood, because I know everything in that profession.
So you know what? I forgot to ask y'all if y'all had any questions, but do y'all have any questions, or can we just start? You gonna get it back? I got you. Got you at the end.
So I see what I feel.
Got you. In general, yeah. Y'all good?
Really.
All right, let's jump into the lesson then real quick, real quick. So this is like all the homework for like this week. Is this one topic right here? Yeah, this one topic. You know. So what I did was I released all the week's homework to y'all early. That's why it looks like it's so much, but it's really a week's amount of homework. You know. So like y'all can start it now. It's the same thing. When you click through it, it's the same, asked in a different way. It's the same topic, you know, just asked in a different way, right? So we're going to be doing linear equations and inequalities in two variables, right? So let's look at some vocabulary. We're going to learn what is an XY plane, plotted ordered pairs, graph, intercepts, x and y intercepts of a line on in the xy plane, the slope of a line, parallel lines, perpendicular lines, horizontal lines, vertical lines, slope intercept form of a linear equation in two variables, point slope form of a linear equation in two variables, and systems of linear equations, right? All the good stuff. All the good stuff. Yes, that same thing from the regions. Yeah. Yeah. Slope is fire.
Yeah, I think I like slow.
Yo, where's my this computer gonna make me start cursing it out? Like, yo, like, do it. Don't worry, you got it, you got it. Don't worry.
Wait, you did it at the end?
Yeah.
Because I kind of.
During office hours.
You can read. Get it and go over it, Professor Harrison.
Nah. So I'm gonna tell you what we're gonna do in a second. Hold on. So 5.1, we're doing solving linear equations in two variables. We now turn our attention to linear equations with two variables, which we will assume to be called x and y. So linear equation in two variables can always be written in the standard form ax plus by equals c. Cool, right? Okay. I'm gonna keep it going.
So 8x plus by is.
Mm-hmm.
Kind of makes sense.
Promise you, this is a real easy topic. It won't take that long to go through. Y'all can knock out your whole week's homework in like a day. It is. It is. It's on both cheat sheets. Mhm. You doing? You four. But we building up to it. So right now, this is the algebra one. This is algebra. But we building up to what's in chapter 4.
Question.
Mm-hmm.
Slope here.
Mm-hmm.
Okay, are you
Yeah.
gonna this?
Mm-hmm. Yeah.
That helps a lot.
Yeah. Yeah, I'm not one of those people that's like, oh, figure it out. Like, nah, I'm gonna show you how to do it. Mhm. That's it. Yeah, that's it. All right. So written in standard form where A and B are constant coefficients and C is a constant. So what is, hold on one second. Hold on one. All right. Let's try that again. So what is standard about this form is that the terms involving variables are on one side of the equation, while the constant term not involving variables is on the other side of the equation. However, a linear equation may not be written in this standard form. In fact, we will soon see several situations in which it is better to write a linear equation in another form. As with any algebraic statement, a linear equation in two variables may be true or false depending on the values for both variables x and y. You're going to see this in your homework. So as we saw earlier in the section, right, a solution to a linear equation in two variables consists of a value for each of the two variables, which we indicate by writing them together as an ordered pair. All right. So let's start by looking at a relatively easy example for linear equation in two variables, x plus y equals 5, right? So it is easy to see a few examples of solutions to this equation. 1 and 4, 2 and 3, 3 and 2, for example. With a little bit more thought, more exotic solutions come to mind. -1 and 6, 1/2 and 4.5, for example, right? On the other hand, not every ordered pair is a solution to this equation. For example, 2 comma 2 is not, right? I plug in 2 for x and 2 for y, that does not equal 5.
This is related
Right.
to what we did last time.
Exactly.
Where
We're
you
just
put
building it up, building up from it.
the +2, +3, +1.
Exactly. So a method for producing solutions, right? In the case that the equation is more complicated, there's still a straightforward method for producing solutions, and we'll illustrate that method in the following example. This says find 3 solutions to this equation, right? 2x minus 5y equals 10, right? I'm gonna show y'all the easiest way to do this. This is the easiest way, right? Pick a variable. I don't care which one you pick. Pick a variable. All right, let's pick x, right? Solve for x, and then just plug in numbers for the other one to get the rest, right? So I'm looking for. Why are you freezing? Come on. Really? I'm gonna wait for you to load. All right.
So you gotta cancel out the variables one by one.
No, pick a variable and then pick numbers to go into it, and then write the answer of the other variable next to it. So let's say I have a table of values, x and y, right? Looking at this equation here, the most natural thing to do should be to plug in 0 for x and plug in 0 for y, right? If I plug in 0 for x, right, this becomes 2 times 0 minus 5, y equals 10. You already know this is 0, right? So this is -5, y equals 10. Divide by -5, divide by -5, y is equal to what?
If I say you lost me, I'm so confused.
So I plugged in 0 for x, right? I'm trying to find 3 solutions to this equation, right? And the way you do it is just plug in numbers and find it. But the easiest number to plug in is 0. So plug in 0 one time for each of them. One time for x, one time for y. That's going to give you 2 pairs. And then I'll show you how to find the third pair. All right. So what's 10 divided by -5? Close. Give me a better answer. 10 divided by -5. -2. Now we're talking, right? So 0 and -2 is a solution to this equation, right? Now plug in 0 for y. Same game. This is 2x minus 5 times 0 is equal to 10. You already know this is going to 0, so this is 2x is equal to 10. Divide by 2, divide by 2, so I have x is equal to, perfect. That's another pair right there. Now I have to find the last pair, right? Now to find the last pair, you pick a variable. We picked x earlier, right? Solve for x, right? So I have 2x minus 5y is equal to 10, right? Solve for x. So I'm going to add 5y over here. What I do to one side, I have to do to the other. So now I have 2x is equal to 5y plus 10. Then I'm going to divide by 2. What you do to one side, you do to the other. Right? So now what do I have? What do I have? I have x is equal to 5 over 2y plus, what's 10 divided by 2 again? 5, right? So now pick a value for y. Give me a number for y. 4. Y'all making it real hard. 2. Thank you. Why'd you pick 2? Okay. I picked 2 because 2 is in the denominator. And what happens when I plug in 2? The 2's cancel, right? We don't like fractions. So 5 plus 5 is 10. And that's it. So what's another solution to this? 2? No, I'm sorry. Hold on. That's wrong.
Okay.
Hold on, that's wrong. What was this? X equals 10. So 10 and 2. Mhm. Sure, sure. Mhm.
Over it, and then like, I'm like an imaginary fraction is like 2/1.
Exactly. That's exactly what's happening. I got you. I'm gonna come back. I'm gonna go back up 1 second real quick. So you asked me for another one, right?
Yeah, some confused.
Give me another number to plug in for Y. Don't overthink it. Give me something better. We just did 2.
5.
No, no, no. What's the opposite of 2? Oh my gosh. Here we go. I got 5/2 times -2/1 plus 5. Right? You already know what's gonna happen. 2 and 2, this becomes -1. -1 times 5 is -5 plus 5, which is
-5, well, 10. 5, no, 0.
0. Very good. Right? So X is 0
Still confused.
and Y is -2.
Understand this formula that I never.
Wait, that was there already. I don't know why I did that. Huh?
I'll never understand this way.
Mhm.
I kind of wanted like a different way. I wanted to do the same exact equation, but in a
Mhm.
different way. Not in that.
Like for me to solve for Y instead of X?
Maybe, I guess.
Or different methods.
It's the same thing.
Like, I just want
I have multiple methods I'm gonna show you. This is just the easiest. That's all. You know? Yeah. You think so? Plugging in 0 is hard? I got you. More ways are pending. I got more ways pending, don't worry. We gonna talk about it.
You know, I'm not good at math. I'm sorry, because I'm not trying to be a jerk. I just don't understand.
I got you.
Suck at this. I'm so fucking lost.
Really? All I'm doing is I have an equation. I have an equation and I'm just plugging in numbers. That's all. And like so one variable is independent. I'm plugging a number in for that, and then it's giving me a response out. And that's my pair. And all those pairs is my answer. I could plug in whatever number I want, but I'm trying to keep it simple, right? 0. Whatever number's in the denominator, positive and negative, like as simple as possible. The answer is the table. This is the answer right here. These pairs. The table is giving you multiple answers that satisfies this equation, right? That's what I'm trying to do. What numbers can I plug in for X and Y to make them equal to 10? Right? Now I could plug in some harder numbers too if I want, but I just want simple, Yeah. I got you.
We use the same numbers, but with a different method.
I got you. I got you. I got you. More methods are coming. Let me summarize this for y'all real quick. Give y'all my special table. All right. So finding solutions to an algebraic equation in 2 variables. To find solutions to an algebraic equation in 2 variables, step 1, choose a value for one of the variables. Step 2, substitute the chosen value into the equation and solve the resulting equation in one variable. That's it. So the ordered pair corresponding to the chosen value with the value obtained by solving the resulting equation in the appropriate order will be a solution to the original equation in 2 variables. All right. Usually speaking, it's easiest to just solve for Y and plug in a value for X. All right. That's the easiest way to do it. I did it in the reverse because somebody said it. I was just following y'all. All right.
For example, right? Well, it says like 2x take away 5 equals 10. I wouldn't be able to multiply or divide 10 by 5 to find.
It would add 5 over, then divide by 2.
So I would add 5 plus 5 and
Yeah.
add 10 plus 5?
Yes.
Okay,
Yeah.
can we try that?
Yeah, we come into that. I got a lot more examples. I have like 14 examples today. All right. One thing should be clear from the method described in the example above. A linear equation in 2 variables will typically have infinite many solutions, one for each value for x or y. This will present some problems from the point of view of solving such equations, finding all solutions. Okay. So now I want to give you guys a method to represent or to show all of the possible solutions for this particular equation or equations like this. All right. And this is how we show all the solutions. All right. We graph them. All right. So graphing linear equations in 2 variables, right? So in another section on linear inequalities in 1 variable, we saw a powerful method for keeping track of solutions of algebraic statements with infinitely many solutions, graphing. However, in the case of algebraic statements in 2 variables, a number line is not sufficient. To keep track of the values of both variables, we will use the xy plane, right? Sometimes called the Cartesian plane, after one of the originators of the concept, the French philosopher and mathematician René Descartes. So, for the sake of reference, we list here some of the most important properties of the xy plane. It is formed by 2 number lines placed at right angles and meeting where both are labeled 0, right? The number lines are called the x-axis. Excuse me. The number lines are called the x-axis, the horizontal number line. The y-axis is the vertical number line. The point of intersection of the axis is called the origin, right? So it looks like this, right? This right here in the middle, this is the origin, right? This is the x axis. This is the y axis.
Oh, great.
I'm not there yet. This is just the graph, right? Okay. The positive x direction is to the right. The positive y direction is up, right? An ordered pair is represented by a point on the xy plane by means of its coordinates. The first number, the x coordinate, represents the number of units in the x direction from the y axis to the point. The second number, the y coordinate, represents the number of units in the y direction from the x axis to the point. All right. So we're going to be graphing points. All right. Everybody remember how to graph points? Awesome. Awesome. So graphing these points, we're literally graphing the solutions to that what you call a table that we found before, right? You're just graphing them on there. And what you're gonna do when you write out the entire graph is you're finding all of the possible solutions to that equation. All right. So here's a nicer looking graph right here. Y'all get the idea, right? You have the x-axis, y-axis, positive to the right of x, negative to the left of x, positive above the y-axis, negative below the y-axis. All right? Okay, so the points on the x-axis correspond to the ordered pair having 0 as a y-coordinate. The points on the y-axis correspond to ordered pairs having 0 as an x-coordinate, right? Okay. Say I wanted to plot the point 2 comma 0. 2 comma 0. Right? I want to plot this point 2 comma 0.
Positive, positive.
Right. So I come across the x-axis to where 2 is, and I'm right here, I'm at 0. This is the point 2 comma 0. That's what they're trying to say. Let's say I wanted to plot the point 0 comma negative 3.
And plot it right on the table.
well, first I go to where 0 is, the origin in the center, right? And then I go down 3 units. So right here. I'm sorry?
The number's negative.
Yeah. You go down. Yeah. X is the first coordinate and Y is the second coordinate,
Got it.
like that. All right?
So X is 0.
Yeah. This is like the first 3 homeworks for the week.
That's not bad. I'm just still stuck on the 2x take away 5 points.
Oh, we getting back to that. We getting back to that. No, we getting back to that. It's coming. Yeah, I'm just building up to it.
This is.
Yeah. I got you. I got you.
Cross my notes out because it don't make no sense.
I got you. I got you. Don't worry. All right. So let's return to our example, x plus y equals 5. So just by inspection, we found several solutions. We will now represent each ordered pair solution with a point in the xy plane. This is called plotting the ordered pairs, right? So I have this equation up here, right? Hold on one second. I'll highlight it. X plus y equals 5, right? We have that equation there. I'm looking at different solutions for it. So negative 1.6 is a solution. 0.5, 4.5 is a solution, etc. Right? And all of these points, right? They line up in a line, right? The line is a solution for every this entire equation. Go ahead. Yeah. I'm getting to that. Yeah. Not there yet, but I'm getting to that. Yeah. Mhm. That's like homework 4 or 5. Yeah. But we get into that. We get into that. Right? So in this question, they were asking us to find 5 solutions to the x plus y equals 5. Here's 5 solutions right here. All right. 1, 4, 2, 3, 3, 2, etc. All right. So the graph obtained by plotting 5 solutions to the same linear equation in 2 variables points to a crucial fact that will be central to our treatment of dun, 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 dun. Coming back with it, coming back with it.
So you said 5 solutions. I put 1 plus 4, 2 plus 3, 2, 2 plus 3, 3 plus 2. What was that one?
0.5 and 4.5. Yeah. I'm more concerned with you just being able to find it than anything. All right. So to our treatment of linear equations to variables, big fact, the geometry of solutions to linear equations in 2 variables, the point corresponding to plotting all the solutions to a linear equation in 2 variables all lie on a single line. Every point on this line corresponds to a solution to the equation, period, right? This fact, combined with some basic geometry, gives a powerful technique to solve a linear equation in 2 variables in the form of a graph. So general method to graph linear equations in 2 variables. So to graph all solutions of a linear equation in 2 variables, find at least 2 solutions, plot the solutions, and then draw a line corresponding to those chosen solutions, right? Not there yet, but we're getting there. I'm happy you guys know what slope is. That means y'all could do y'all homework already. Oh, you did? Nice. Nice.
And I had to plot it on the Excel and
That's a headache,
yeah, it was,
but possible. I'm not gonna do that, but it's possible. Yeah.
What
All
about?
right. Yeah. So notice that geometry comes into the picture due to the fact written down as far back as Euclid that two different points determine a unique line passing through them. The fact is, what allows us to buy two solutions get infinitely many solutions free. Combined with our method for producing solutions to linear equations in two variables above, we are hence able to graph any linear equation in two variables. So let's graph the one that we had before, 2x minus 5y equals 10, right?
But
Mhm.
because I didn't understand the methods of these.
You plug in 0 for x, plug in 0 for y, and then you just pick one of the things and you solve for it. Hmm? Yeah. It's not bad, I promise. Hold on, let me get my pen real quick. Look, we'll do it again real quick. All right. Plug in 0 for x, right? So I have 2 times 0 minus 5y equals 10, right? You know that this is 0. So negative 5y equals 10. Divide by negative 5, which you do to one side, you do to the other. So y equals negative 2, right? So when x is 0, y is negative 2. That's simple, right? Let's try it again in reverse, right? I'm gonna do it over here. I'm gonna plug in 0 for y. So I have 2x minus 5 times 0 is equal to 10. You already know this is going to 0, so that gives me 2x is equal to 10. Y was 0 now, right? So now divide by 2, divide by 2. X is equal to 5, right? So x is 5, y is 0, right? I only need 2 points to graph the line. That's it.
So now why is
Right.
it?
Yes. So from these 2 points, I can actually graph this line. Let's say I have an XY plane here. Yeah. So we're gonna have what? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then we're gonna have what? -1, -2, -3, -4, -5, right? Then we're gonna have what? -1, -2, -3, -4, -5. You get the idea, right? So let's plot these points. I got 0, -2, right? So where's 0, -2? Not the x-axis, the y-axis, right? So we go across to where the origin is 0, 0, and go down to -2. So right here, right? The next one, 5, 0, where's that? On the x-axis, right? So I go across the 5, 0, so it's right here, right?
It's 5 zeros.
Right. Here's the hard part. After that, you got to make a line. It does. So the line right here, that blue line, is a solution to every single question, every single possible answer for that equation, right? So the equation what was the equation again? 2x minus 5y equals 10. This is every solution to it, the blue line, right? The pink stars are two solutions that we found easily, right? And then that's it.
We have another problem. I need to practice this. It's
I got a
not
ton.
Here yet.
I got a ton of problems. I'm coming with them.
I need at least like 5 more of these equations.
5 more?
Yeah, I have to practice.
While I sip my coffee, you want to go try this one on the board? Go ahead.
And then you want us to solve for x first, right?
Whatever you want. Give me a graph.
And we can choose whatever number we want.
Whatever you want.
What if I want to choose 0?
Go ahead. That's what I would choose.
0, so then.
Because between me and you, I'm bad at math.
So, okay, so then, just like we did up here with the x, so now it's gonna be 3 parentheses 0.
Yeah. So the class was asking if you could go do this on the board. They were asking if you could go do this on the board.
Oh, on the board. Oh, I was,
You want to do it on the board? Here. I got red, I got blue.
you want me to make the whole class fail?
I mean, it's okay. They offer it next semester. Just not in the middle. You do it on all the way. Yeah. Go ahead. Come up.
Please come help me, I don't mind. 3 plus
This is the perfect time to get it wrong. Stop being graded.
12, right, so we're gonna do the little x, y, graph. And you said I can choose 0,
Mm-hmm.
so then this becomes 3 parentheses 0 plus 4y equals 12. Am I supposed to do 4 divided by 4 and 12 divided by 4 now? Okay, so 4 divided by 4 gets canceled. So 12.
What happens to the y?
4 equals 3.
Where's the y?
Like that?
No, it's next to the 4.
Y, sorry.
No, just on the top. Because your answer is y equals 3.
So that makes more sense.
Mm-hmm.
Okay, so y is 3, correct? Is that correct?
So when x is 0,
When x is 0,
y is 3.
is 3.
Mm-hmm.
Does anyone understand that?
I didn't. No, I just multiplied,
Okay.
added everything, and I got a 0, 3, and then I got 3 again.
Why don't you come up here and show us that method that you did? I can erase all of this and you can show us the method you just did.
I even got another eraser if you want.
You want to? Okay, so what I did, guys, was, so remember, he told us to do a table for x and y and to solve for x first, but you can choose whatever number you want. I just felt like 0 was easier,
Me too.
so I chose 0. So then I put 3 parentheses 0, which is 3 times 0, right? Which is automatically 0. Plus 4y equals 12. Now, in order to simplify this, is that how you say it? Like, in order to cancel out
You wanna
the
solve for y.
Right, to solve for y, I did 4y divided by 4, which automatically gets canceled. And what you do to one side, you have to do to the next. So I did 12 divided by 4y equals 3, because 3 times 4 is
12 divided by just 4, not the 4y. Yeah. Mhm. So you have 0, 3.
y equals 3, when x equals 0.
Now I need 2 points to do a graph. So what's my second point gonna be?
So the x is gonna be at 0 and the y is positive 3, so it would be here, right?
Yeah.
Okay.
But I need another point on that table. You got 0, 3, I need one more.
Yes.
Oh, yeah, so now we have to solve for what?
If you want to.
Solve for y already, you just want a different number.
A different pair.
Anybody else?
However you want to do the pair, no pressure. You want to go? Go ahead. I even got a blue marker if you want to chime in. At the cafe, they just got cinnamon. Yo, I'm hyped right now. So just for the recording, all right? I'm just gonna recreate what you did. So you plugged in 0 for x plus 4y is equal to 12. Then you had 4y is equal to 12. Then you divided by 4. So you got y was equal to 3. So we found when x is 0, y is 3. All right, go ahead. Your turn.
Well,
3x plus 4y equals 12. So I figure y'all could probably knock out the first 2 homeworks after this. They really, really, really simple. They're not hard at all.
Y to be 0, right?
Yeah.
That makes perfect sense.
Good.
So he chose 0 for Y. That was actually pretty smart. So it's literally just the opposite. That's so smart.
Oh man. All
Okay.
right. So just for the recording, right? What was said in class, we're gonna actually choose 0 for y. So this becomes 4 times 0 plus 12. Oh, equals 12. Sorry. This becomes 0, so this becomes 3x is equal to 12. Then we're just gonna divide by 3. What we do to one side, do to the other. So x equals 4. So right. So this is 4 comma 0. There we go. All right, that's my 2 points. After that, graph it. That's the end of the conversation.
We always choose 0.
Mhm.
Great.
But you do have options. All right. So 1, 2, 3, 4.
Yeah, like if
We already found the point. Yeah.
I,
We kind of put it like inside out.
yeah.
And this is -1, -2, -3.
Tell us how
4.
you did it.
How I did it?
I want to know how you did it. Girl, tell you, I'm very good. I'm definitely going to grab this one.
Why?
Dropping it because you passed the test, okay? You passed that test, you did not know
That's true. Yeah. Yeah.
He did, yeah, he passed it, right?
I actually had to go pick it up. That's why I was a few minutes late today. All right. So we have 0, 3, right? So where's 0, 3 again? I forgot. No.
Well, 0 for the y-axis.
Yeah, on the y-axis, right? So 0 and then up to 3 right here.
oh,
X first, then y, right? So this is the point 0, comma 3.
That's.
Right? Where's 4, 0? Good, right? Go across the 4 right here. This is the point 4, comma 0. Right?
And then you would draw your line.
Then you draw your line, right? What's a good color? This one.
Not that bad.
Hmm? And this is for the equation 3x plus 4y equals 12. That's it. Yeah, you have to find 2 points. Then you just plot them, connect them with a line, and that's it. You know?
If we could always choose 0, it's not.
Yep. And if 0 is not an option, what you gonna choose?
1.
No.
1.
Whatever number is in the right. That's it. Whatever number's in the denominator. Right?
And what would that be?
Whatever the denominator is.
Okay,
And it's a fraction, but what if it's not?
right, what if it's not a fraction?
If it's not a fraction, you smiling because it's easy. But when it is a fraction, whatever number's in the denominator.
Okay,
Mhm.
so when it's a
Yeah.
fraction, choose
Yeah.
the denominator as we
Right.
plug in.
Mhm. Positive and negative. All right. But zero should always be your first option. The denominator is your second. All right. Mm-mm-mm.
Think I was better not knowing that he created a denominator would be.
Why?
It's like boom, 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 boom.
Why? What's the worst that could happen?
Wanna fail, yeah, they don't wanna fail.
It's okay.
It's tearing me apart.
Failure is a part of life. Mhm.
No, not at my age.
Yeah.
But it's not at my age, professor.
Yeah. So when I took Math 23, right, I actually failed my second test.
Really?
Not the first one, the second one. Yeah. So I failed by my standard, right?
Oh,
I
so you
feel-
felt like.
Yeah, I'm supposed to get 100 on everything, right? But I got one question wrong on my second test, so I failed. I felt real bad.
Yeah.
Yeah.
Man, yeah.
Like, you know what it was? I ain't read the question right. Like I did greater than when it's supposed to be less than.
No. I'm like, what the fuck was you doing? Yeah, but.
Right?
What was you doing?
When I was in what's that class, phonics or whatever, with the words and the definitions and stuff, yo, I never forget one time I got a test, I got 99. I was so mad at the teacher. I'm like, yo, you sure you right, man? Like,
Now.
yo, communications was so hard. Oh my gosh.
Next semester.
No, you be good. It's hard for me, but y'all smart. Y'all smarter than me. I mean,
For nursing, he said that we have to.
I think you have to. Yeah.
He said I needed math. But I don't know, that professor.
Take classes.
He's
I don't
like,
think.
oh my
Yeah.
God, I'm like 5 minutes late, and he marked me absent. Oh no.
Some professors are like that.
With my advisor, you're not gonna play with me like that.
Some professors are like that.
Yeah.
You know?
You know,
You should speak to your advisor.
Yeah.
my professor, my professor dropped me from my class.
Yeah. Yeah.
Like, those practice, you're like.
Yeah.
Let's say you're like full time all the time, then like something happens, like.
Not fun.
Right.
Bro, still like, that's it, that makes no sense.
Right. Got you. Yeah. Yeah. That's true too. That's true too. Yeah. That's true too. All right, let's look at this. Where the line intersects the y-axis. Likewise, the point whose y-coordinate is 0, the point 4, 0 in the previous example is the x-intercept of the line, or the point where the line intersects the x-axis. We will often refer to these two special points on the line in the xy plane as they stand out on the graph. Let's say we're going to graph this now. Y equals 1 over 4 x minus 2.
Decimal, or you want it as a fraction?
What are you going to plug in for x? Tell me.
0.
No.
The denominator.
What's the denominator?
4.
Exactly. So when x is 4, what's the y value?
0.
No.
The numerator.
Look at it. I just plugged in 4 over 1, right? So what's 1 over 4 times 4 over 1?
What?
No. What's 1, right? Becomes 4 over 4, which becomes 1 minus 2, negative 1. Right? That's the reason why I picked the denominator. Right? Give me another value to plug in.
So what you do is you switch I mean, if it's a one over something, but if it's another, um, it's another fraction, it wouldn't be
Mhm.
reciprocal.
Kind of. That's what I'm choosing. Yeah. Mhm.
For y as well?
No, I'm just plugging in for X.
Oh.
That's all. So I already plugged in 4. Give me another number I can plug in. Don't overthink it. No, give me something better. Actually, I could plug in 0. That's a good one. Hold on. That's a really good one. 1/4 times 0 is 0. This becomes y equals -2, right? So when X is 0, y is -2. Give me another one. I know I don't need 3. I'm just trying to prove a point here. Give me another number to plug in. All right. Well, that's what I'm looking for. Mhm. Yeah. Not 2. So, what's in the denominator? And what's the opposite of 4? -4. Right? No, just -4. Look. So when I plug that in, what does this become? This whole thing is -1 minus 2. This becomes -3. So when X is -4, Y is -3. Those are literally the easiest points you can plug in for this. Right? I only needed 2 and I got 3 answers. Look at that. Light work.
Wait, Professor,
Mhm.
I'm still stuck, so. All right, I plugged it in, I did y equals 1/4 times 4, take away 2, right? Left me with 4/4, take away 2. What did you do with the 4/4? You made that one?
That
One
becomes
whole?
1, right?
Okay,
So
so
then,
now it's 1 take away 2,
mhm,
and that is why you put -1, correct?
right. Mhm.
So,
So when X is 4, Y is negative,
okay,
right?
now can you I'm sorry, I just process things a little bit slower, can you walk me
Fine.
through the second plugin now?
So now somebody, I don't remember who, said plug in 0, right? At first I was against it, but I was like, you know what, that's actually for X, but that's actually a really good answer, you know? So we plug in 0, 0 times 1/4 is 0. So this is just Y equals -2. So when X is 0, Y is -2.
Wait, hold on, so I put y equals 1/4 parentheses 0 take away 2, so canceled out. Now you're saying y equals -2 and that's it, that's it, so I don't gotta do nothing else.
That's it.
It solved itself for me.
Mhm. And then the one that I wanted to do is I wanted to do -4, right?
Let's try it.
So when we plugged in -4, this became -1 minus 2, which is -3.
Right,
Yeah.
I
Simple, right?
guess.
Now I got 3 answers here. I only need 2. Graph it and we're done. That's it. Yeah. When you try the homework, you'll see it's real simple. Real simple. What I need 4. Huh? Yeah. During office hours. During office hours.
You're gonna give me a heart attack.
So like in like 9 minutes. You want to take the test home? All right, I'll let you take it home. I get it. You probably want to show it off to your kids and everything. I get it. You can put it on your fridge. Mhm. Yeah.
We're gonna plug in the 4 and the -1 and the 0 and the -2.
We're just gonna graph it right now. So what I'm doing, I'm looking at the numbers that I have, and I saw that 4 was the biggest number there, right? So that's why I'm just putting 4 in every direction, right?
But normally it would have more numbers there.
It could, but we're just keeping it simple, right? Just keeping it simple.
And so now, Professor, you're gonna go 4 to the right on the x-axis, and then you're gonna go.
Let's see, 4 -1. So where is 4 -1? Tell me.
So, on the 4, the -1, going upward, right?
No,
That one?
it would be 4 and then you go with 4 on the X axis.
Uh-huh.
On the right side.
Because it's 4 negative.
Good.
The y is negative.
So this is 4 -1.
Oh,
Oh,
right.
you go on the X.
Right?
Yeah.
You see what I mean when I say?
Yeah.
So where is 0, -2?
0, -2. It will be
Down.
0.
No, what?
No, wouldn't it be?
On the y-axis, 0, -2.
So
Good.
Good job, guys.
What about the last one? The last one was -4, -3.
-4 on that.
Mm-hmm. Good.
on the y-axis.
Yeah.
Right here.
No, on the.
So that would be it. And now draw your line so I can see how fast it's
4,
going.
-3.
Yeah.
I mean, y'all know I'm not an art major. I'm over here trying.
Oh, Lord.
Oh, see, I done messed it up. Hold on. Let me try it again. Let me try it again. Something like that. I don't know. I don't even remember what we were doing. What was this? 1/4 x -2. So this is y equals 1/4 x -2. And that's it. Questions on this?
No, actually, like,
Good.
I'll look here.
So y'all can finish y'all first homework, no problem?
Yeah, so.
All right, good.
Yeah.
It's all of this. You might even be able to do more. Some of y'all said y'all know how to do slopes, so that's the whole lesson for the week, so you know? Yeah, I got you. All right, so can somebody give me an attendance sheet, please? All right. Huh?
Okay.
Got you. No problem.
I got it.
Yeah.
So
Let me stop sharing.
y'all just like email you, just know when I get it.
Yeah, just come in when you can. Just come in when you can.